Hello and welcome back to the Ops Show, where we bring you the trials and tribulations, automations and collaborations from the world of DevOps and the greater developer experience. I'm your host, Tristan Pollock, and as always with CTO.ai founder Kyle Campbell. In our best show yet, we have Charity Majors, co-founder and CTO of Honeycomb.io and co-author of Database Reliability Engineering. Welcome to the show, Charity.
Thanks for having me.
We're really excited to have you, really excited to talk a little bit about observability and get a little peek behind the wheel of Honeycomb. But first, start and give us a little bit of your code journey, where, how you first got into code, and then, what some of the steps you went through to end up as a founder of such a great tool.
Here, because I noticed that my machine is at like a load average of 125, and so I'm just like killing off as much stuff as I can, hoping to bring that down a little. You can hear me all right?
Yeah.
You can hear me?
We can hear you all right.
All
Yeah.
All right,
little bit of ebbs and flows in the memory usage, I think. Yeah, load average.
A little bit of choppy. Yeah, well, I have a bunch of stuff, so hopefully it gets a little better.
Yeah,
it's like what they say, cobbler's kids go without shoes. I feel like that's what like systems people on our laptops, we just don't even attend them. So I'm a very accidental technologist. I went to school for classical piano performance in Idaho when I was 15, and then I realized that all of the music majors were still poor, like a decade after they got their degrees. I didn't want to be poor. So I've been an ops geek, right? Like I've made sort of a niche out of being like the first or a very early infrastructure engineer who joins a group of software engineers when they have something that they think might be a real thing, and we help it grow up, right? And that's kind of what I've done. I was at Second Life for years, and a couple other startups, and then I was at Parse, and that led me to Facebook, and that led me to Honeycomb. So,
oh, cool. Yeah, Second Life. Wow, that's a trip. Is
right?
the community still flourishing there?
It still is. Like, it's one of tech's most successful failures, I feel. Like, they're still like very, very profitable. They're actually profitable. They actually bring in money. And they've still got like 100 million users, and then nobody ever hears about them anymore. But yeah.
Wow, that's cool. And what I guess I didn't know you had stopped along the way at Facebook. How was your experience over there?
Well,
what you can share on camera.
It was a non-consensual, like I never applied to Facebook, and I wasn't too stoked about the acquisition. It was one of those things where like they came in and they announced to us we'd been acquired, and like a few people burst into tears. They weren't exactly stoked about the acquisition. It is what it is. It's a big company that profoundly believes that it's doing the right thing, or that they don't care if they're doing the right thing or not. I can't really decide which, and it wasn't for me. But I will say that coming out of Facebook was the first time in my life that I've ever had a pedigree, that I've ever had people chasing me going, take my money. So like, if it wasn't for Facebook, there would be no Honeycomb. So, that, and I bought a house with my blood money. So there we are.
That's through the acquisition of Parse, correct? I think is it Ilya, one of the founders? I think I met Ilya at one point along the way. Very impressed. And Parse was something that I think was foundational in what I think then was called sort of backend as a service. Now I think we talk about it more like serverless, I guess. But you must have really also been able to cut your chops on the ops side quite a lot through that journey, dealing with some pretty interesting problems of scale, I would imagine.
Yeah, we were doing a lot of things sort of before, like we were doing microservices before there were microservices, right? Before there was a term for it or a bunch of best practices. We were doing a lot of really hard problems around co-tenancy. We had 60,000 mobile apps when we got acquired. We had over 1 million apps by the time I left. And whenever you're dealing with like 1 million apps, like it's an interesting set of problems, because you learn that you need to deal with them naively, right? Anytime you have to think about an application or a customer, you failed in some fundamental way, because that doesn't scale, right? And like the fundamental problem that led us to start Honeycomb was very much germinated there, where like, okay, so our API was this fixed pool of unicorn workers, right? Ruby HTTP web workers, not a threaded language, right? Backed by a database, became many databases, right? And then we had, MySQL, Redis, many MongoDB clusters, Cassandra. And so, your pool of workers is ever growing, but it's also becoming ever more fragile, because whenever any one of those backends it's a little bit slower, every worker in your pool fills up with a request that's hanging on it, like waiting for it. And so it might be only one application that's hosted on this database, and yet it can take down, for all of your million users, it would take everyone down within seconds, right? Which is way too fast for anything to respond. And then you're stuck with this case of, well, everything got a little bit slower. So what's the cause of it? Because when something gets slow, everything gets slow, and it's very difficult to figure out what caused it versus what's the effect. And like fundamentally, like it was just an impossible problem given the tools that we had. Like when you've got monitoring tools, metrics tools, you can tell that there are problems, you can tell that there are spikes, but you can't drill down into it. You can't see, well, what is the problem? All you can do is like scan with your eyeballs and try and like pattern match, right? Which is fine if your system is failing in predictable ways repeatably. And it completely fails if it's a different app that's hitting the iTunes top 10 every day, right? When you've got logs, if you know what to search for, you can find it every time if you remembered to log it, and if you know what to search for. But if you don't know what you're searching for, you're screwed, right? And so like, Parse would go down. We would like, we had a bunch of tools to like just get it all up no matter what. But then like trying to figure out what had actually happened, it would take us days. It was often just open-ended. We didn't know. We just turn it back on and cross our fingers and hope for luck, right? Which is like the dirty secret of systems. It's just like, how many outages go fundamentally unexplained forever? Like, it's humiliating to me as someone who's supposed to be good at this stuff, right? So like, we tried every tool out there, every APM, monitoring, whatever. The first like glimmer of light that we got was when we started getting some data sets into Scuba at Facebook, which is this butt ugly, like aggressively hostile tool that does one thing really well. It lets you slice and dice in near real time on dimensions of high cardinality, right? So your unique IDs, basically. And suddenly we were able to, break down by endpoint. Well, let's say, are all the endpoints slow? No, it's just a few of them. Well, what do they have in common? Maybe it's only the right endpoint. So is it all of them? No, it's just the ones to these 3 replica sets. Well, what do they have in common? And just like, so you're following the trail of clues instead of like scanning through your dashboards and looking for a pattern that you can jump to the end on, right? And the time it took us to understand and like alleviate these incidents dropped from like days to seconds, like not even minutes. Like it wasn't even an engineering problem anymore, it was a support problem. And that made a big impression on me. And of course, when I was leaving Facebook, I kind of went, oh shit, I no longer know how to engineer without this stuff. Like it's become so fundamental. These are my 5 senses to my systems. It's not just what lever that you pull in case of emergency to get the site back up. This is how I navigate the world every day. And the idea of going back to just having monitoring tools and logging tools was like, not having my glasses and trying to drive down the freeway, which is not.
That's a great analogy. Yeah. I forget who it is, but there's a CEO at one point said to me, or I read somewhere, something along the lines of, there's no one ever makes a wrong decision. They're just missing context, right? And,
yes.
And the basis for understanding is context. And what I love about what you've been doing over the last couple of years is not just how awesome, Harness is as a product, how you've been advocating for observability and sort of like going up against the traditional assumptions of what people are calling observability and debunking them into clearer categories for people to understand how that context actually drives results that the business and the developers care about. Would you care to unpack some of that for us? Because we can see sort of the like hard fought lessons that led you there, but what's your current state of contrarian view and how you unpack these things and like obviously the benefits of them?
Yeah. Oh, that's such a good question. Such a large question too. So I really believe that, engineers, so like as a backend engineer for years, I would just like grumble, I don't care about the product. I just care about the problems in the backend, right? And it took a while for me to realize just how deeply untrue that was. And I think that that's untrue of anyone. Like we all yes, we geek out on our problems and our, what the stuff that we do every day. We're fucking lucky. Sorry, I'm dirty mouth. We're so lucky. Like, we get to fix puzzles every day for a living and get paid a lot of money to do it. Like, throughout all of human history, like, how many people have been as lucky as we are? Like, not many. But that's not enough. Like, it does have to connect back to something that makes a difference in the world, or, like, maybe this is an artifact of getting into your 30s or 40s where you're just something like, oh, right, maybe what I do should matter. But, like, I do believe that engineers should take more interest in the business. I think that they should care a lot more about its impacts on the users. I think that there's this wonderful sort of merging of streams that's happening right now. I wish that I had worked with product people and designers while I was an ops person. I never did. That's a huge regret that I have, and I'm trying to play catch up right now. But, like, which is just all kind of a way of saying that, like, observability is really key to, like, linking these streams. It's key to making you interested in your job, because the more you can understand the impact that what you do is having on people, the more interested you will be. Like, they say that what drives us in our work is autonomy and mastery and impact, right? And, like, if you can't see what you're doing, what chance do you have of really caring deeply about your work, right? So I don't know if that's contrarian. I think everyone would agree with that. But, like, back to like where we are now. So I think that we've got now is I think that, like, over the next 5 years, we're going to see monitoring, logs, and APM categories just disappear. I think there's only going to be observability. And I think that, like, those categories were born out of scarcity, right? Because hardware was expensive. And so we had to make all of these trade-offs. Like, what is a metric but the least amount of data that you can store? Like, it's a single number to get some insight into your systems, right? Well, observability is based off of these arbitrarily wide structured data blobs. You can derive all of the other data types from that. You can derive traces, you can derive metrics, logs, and you can't go in the other direction, right? It's like asymmetric key ciphers. Like, you can't go from metrics, logs, and traces to observability, but you can go from observability to metrics, logs, and traces. This is controversial only because there are so many businesses out there who have built billion-dollar businesses on top of selling you metrics, logs, and traces. So now they're like, buy these 3 things from us, and it's like, no, that still doesn't add up to observability. And not only that, but you're asking people to pay you to store it 3 different times at least, and then you're still having to sit in the middle and copy paste IDs around to link one to the other, and that's nonsense.
Yeah, more profitable to lead the horse to water, right?
It's way more profitable for companies out there who are like, haha, but it's very cynical in a way, which is why it kind of gets my goat.
Well, I think that's where I see the contrarian in what you're presenting, which I think is great, because I think a lot of tools that are kind of, especially getting more popular out there, just are not putting these kinds of concepts at the forefront. And like, we have this hypothesis from things like the Stripe coefficient, which says that there's $300 billion in developer productivity loss every year, that, like, some of these core concepts just generally have to get reevaluated. And, like, the infrastructure has to get smarter, because it's not about the human trying to understand the raw, context. It's about machines delivering that context at the right point in time, so that a developer is doing the things that are the most meaningful, right?
I love that Stripe report, because it showed that optimistically, like, this is self-reported. People are saying, yeah, I waste half my day. I just waste half of it. Yeah, doing all the crap that you have to do in order to get to the stuff that you want to do, right? And all that stuff that you have to do is a lot of it comes down to not having observability, because you're having to orient yourself, you're trying to reproduce bugs, you're working on the wrong thing, you're working on it in the wrong way, you're not able to see that if what you've done is doing what you wanted it to. There's just a lot of fumbling around in the dark. So, like, Honeycomb is a team, we have had only 8 or 9 people writing code for the past 2 years. Like, we're doubling that now, but, like, that's 8 or 9 people to do everything from the custom built storage engine, query planner, application, microservices, integrations, security, on-call, UI, UX, like, fucking everything, right? That's a lot. And we've got, like, 300 teams who pay us money to stay alive. And we have, like, no obstacle. The only way that we could possibly do this is by having our own tool, because it means that we don't ship broken shit. Like, it means that, like, the amount of time, like, my developers still waste some time, like everyone does, but I bet it's more like 10 or 15%. And when you amortize that over months and years, that is huge, right? And little frustration and just the, like, but, like, most at the productivity levels of most really well-run engineering orgs that I have worked at, we would need 3 to 5 times as many engineers as we have to do the same amount of work. Like, there is a huge efficiency gap that can be, with better tools.
Yeah. Well, so let's play this out, right? Because the progression towards, let's call like the ever intelligent cloud that enables us even more to fulfill our, prophecy as creative programmers, right? Where does this go? I think you've nailed the observability piece of this. And what I often think to next is, how do I take the right action based on the information or the context I'm driven? And that's where we start to hypothesize around this idea of the workflow. And we've been experimenting with how to enable a workflow that can create a reinforcement loop, because ultimately your goal is to influence behaviors. How do you think about that? And where do you guys see that going with your approach and other tools out there? Because I think that's where things like, not to call anyone out, but like Kubernetes, that's a tall order for something as complex as a basic system like Kubernetes is to drive that fluid experience. And so if you have Kubernetes on one end, and let's say Heroku, which is an opinionated way of working on the other, how do you think we find this place in the middle?
Right. Well, I think that every single one of our systems are snowflakes, right? They're these complex socio-technical snowflakes, which is why you can't just give someone a runbook or a playbook and go, this is what worked for me, this is what worked for Google, use this too, right? It actually does take experts. And this is where I feel like ops people like me are most useful in the near and distant future, is just those people who deeply know systems and can help to debug these. You mentioned feedback loops, and I've been yelling about putting developers on call for years now, but that's because it's all about constructing that really virtuous feedback loop of only delivering the alert to the person who wants it, who needs it, the person who's empowered to fix it, who's able to fix it, who knows how to fix it, and who deeply actually wants that alert, because that's how they know that something's broken. Like, the longer a bug is in production, the harder it gets to find and fix, right? And what we've seen is that, like, when you can kind of kickstart this instead of like TDD, like, yes, you need TDD, not saying no to TDD, but like, if you loop observability into that, like, TDD achieves its simplicity by abstracting away everything about reality, everything that's complex or messy or multi-tenant or anything. It's just like, boop, doesn't exist, right? Well, you kind of got to reintroduce reality. And so, like, when you're writing code, if you're writing it with an eye towards instrumenting, so that future you in like an hour is going to be able to understand, how are you going to understand if this is working or not, right? And then if you just make a rule, don't accept a pull request unless you can understand, how am I going to know when this is not if, it's when. How am I going to know when this is broken, right? So you write code, you instrument with that in mind. You hopefully have CI/CD hooked up so that it's a very short interval. Anytime, and so there's almost atomic, right? So that anytime you merge to main, it kicks off a process that results in your code being live in production within hopefully minutes. Like, that's the ideal, so that people can rely on it, so it can be muscle memory, so that it isn't, well, I commit my code and then I either kick off a deploy or I wait for someone else to kick off a deploy. You've got to get rid of that. It needs to be automatic, so that you write your code, you merge it, wait a few minutes, and then you go look at it, right? You look at your code through the lens of the instrumentation that you just wrote, and you ask yourself, is it doing what I expected it to? And does anything else look weird? And weird is kind of irreducible, right? That's the irreducible complexity, because if you're looking at it every day, you will develop like a sixth sense for, this doesn't look quite right? And then if you had the tooling to reward that instead of punishing that curiosity, as our tools will often have, so that you dig in and you figure it out. Like, we find that teams catch like 80% or more of all bugs like right there before it ever has a chance to bake into your system and get crusted over and become part of the new normal and become hard to find, right? Like, you find it right there because you have that original intent in your brain. You know what you're trying to do, right? And then you go and you look at it and it's so simple, but like, very few teams have this. Anyway.
Yeah, I think the name of the episode might need to be observability driven development. Is that what I'm hearing?
I think so, yeah. Because like, I think that's like the building block that you can start to build healthy teams, healthy systems on top of. Most people's production systems are these hairballs that the cat coughed up that nobody's ever understood. Literally nobody's ever understood them. And every day they ship more code that nobody understands onto this hairball that nobody's ever understood. And then they wonder why it's a nightmare to be on call.
Yeah. Well, I mean, they develop this fear of dark corners and this fear of the release, which means you end up staging things for 3 weeks, and then by the time you release it, it's no longer, you know, in the shape, or the requirements have shifted.
Nobody remembers. It's not fresh in anybody's head. Yeah.
How have you seen this improve? I mean, one of the things I've seen as a barrier to entry for this is build times. I mean, we always start off with a build that's, you know, instantaneous, but then it grows as we start adding tools. We were talking to somebody today who Cypress was the big culprit. You know, what have you seen there? What have you seen with making it available in a safe place to review it? What are some of the tools that you'd recommend development teams check out that maybe plug into how Harness works as well?
I don't really care what tools you use. Like, I've seen people be successful with all kinds of tools and fail with all kinds of tools. What I think is important is the elapsed time. Like, you have to work with tools that are fast, parallelizable, debuggable. You know, using tracing, people can instrument their build process with traces so that they can actually visualize where that time is going and just slowly chip away at it, right? Mm-hmm. Anybody who has like an hour of build time is never going to be in that tight virtuous loop, right? It's got to be minutes. It's got to be so much time that you can't get distracted or can't page in and page out like an entire different project. But that doesn't mean
the XKCD article comes to mind. What are you guys doing? Compiling while they're fighting with lightsabers?
But that doesn't mean that like it has to be live and users have to be seeing it immediately, right? It just means that your code has to be in production. This is where like feature flags come into play. This is where like there's I feel like the whole center of gravity of tooling right now is in the middle of a big swing away from like staging and pre-production to production. And I don't want to say that there's no value in staging environments and all that stuff. There's some value. I just think that we need to like invert the ordering that we care about them, right? Instead of like you were just saying, investing like so much time and energy into like all these elaborate pre-production environments, maybe one per developer, everyone gets an environment, you know, and all this stuff. And then it's like, well, we need to do some stuff for production and we're out of time, right? Like that can't be, right? Like production has to come first. We have to build our tooling for production first. And then with your leftover time, do all this elaborate stuff in staging. But I honestly think that a lot of the stuff we do in staging works to our disadvantage rather than our advantage by creating hurdles and time and all this crap before stuff gets into production. Code is dead unless it's in production. The only code that matters is code that's in production, period.
Yeah. I guess everything is sort of like a shift it from one pocket to the other solution to deal with the current state of technology. And, you know, talked a lot with people and hope for a world of like hydrated or atomic build, you know, being reproducible builds. If your build fails, you can recover it from a stage. Preview environments seem to be one of the things that I see people try to adopt quite often. What I'd be really curious to hear your feedback on is, I mean, I think more and more of our software development is actually moving to the cloud and is almost cloud first. And you need to be almost more of an ops person to be successful. And there's this weird compromise between harnessing the power and then the orchestration challenges of like not having that local feedback loop. How do you think this impacts things? I mean, in the short term and the long term, where do you see this going?
Well, I feel like, you know, the last, 10, 15 years or so were all about, DevOps was about yelling at ops people who learn to write code and like, message received, like we all write code now. But I feel like now, like we're well into like the second phase, which is like, okay, software engineers, your time, your turn to learn to write operable services, to learn about, you can't be a good senior engineer without a fair amount of ops chops now. And I also feel like part of what's driving the shit that like, it's never not better to write code with observability. Like, it's always simpler and easier if you can see what you're doing. But it becomes mandatory when you have microservices because you blew up the monolith. You could attach a debugger and step through it in the monolith, right? And you had all that context, like you were just talking about. You had all of that context that stayed with the process, just stepping through it. Now you've blown that up and you can no longer step through your code. Now, a lot of it's been exposed to, the outside world, to operation stuff, right? So like part of the way you can think about observability, like the way that we do instrumentation, we pack all the context, is that we're taking all of the context and just shipping it along with the process from service to service, so that you can tell, like, at the very last hop, you can tell like what value was set at the first hop and so on.
Yeah.
So like, I guess that wasn't really your question. You were asking about cloudy stuff, and like, yes, absolutely, everything's going to the cloud. Anybody who's working on anything that isn't going to the cloud should like feel I don't know, like something walking over their gravestone, like their corpse, send a shiver down their spine. They're working on the wrong thing, is what I'm trying to say. And yes, that means that like our standards for operability and operation stuff are being raised for everyone, because you're not isolated anymore. You're not insulated from the real world anymore. And I feel like all of the infrastructure as code. Like honestly, I feel like right now what we're starting to see is this great split between infrastructure and non-infrastructure, and everybody whose mission is not infrastructure is looking for ways to offload that to other people, right? As they should. I have not gotten to the colo to like flip a power strip on the MySQL master in like years, and I don't ever plan to again, right? AWS has my ops people now, and like as we get better at these things, like that level of abstraction is just going to keep creeping up the stack, which is good. So if you're someone who loves infrastructure, you should go work at a company who does infrastructure as their mission, right? And if you don't, work on somebody whose business is something else, but make sure that you're constantly trying to focus as many. We all have limited engineering cycles, right? It's a limited resource, and we should be focusing as many of them as possible on our core business differentiators, not on all the other crap. Like I started out as a systems person. I did DNS, I did mail, I did all those things. I do none of that shit anymore, right? Like Google does it, like Akamai does it, like all of this is good. We can apply those same skills to helping like our businesses use their developer resources much more efficiently by making use of cloud providers who will always do those things better than you can because it is their core business.
Yeah. One of the things that I think about a lot is, I was part of a really old shared hosting provider called Hostopia that was, was licensing through telcos, and it was like FTP and PHP and like easy site wizards. And you were like, that was how we built software in 2002.
Hell yeah.
And now there's these distributed systems and cloud, and it feels like it's also got so much more exponentially complex relative to the available talent. And so I think a lot about what those abstractions are from a leverage standpoint. And like, it feels like in many categories, because there aren't necessarily enough of these really strong cloud infrastructure providers out there, where there's an obligation overall to like make these tools more accessible through whatever abstractions we have. Because if we, just like adding that context into observability, if we can actually make the way we work and the way we interact with these systems more intuitive, so we spend less time on domain specific languages, I think that's a win overall. Have you seen strong influence in how you are abstracting different complexities, and how people are using specifically Harness maybe as a way to interface with, Honeycomb to interface with their systems in a way where that's not just from an observability standpoint, but an actual interaction standpoint for provisioning, releasing their software? Is that producing meaningful results overall in simplifying that process?
I'm not sure I answered the question, but I think maybe I do. So I feel like serverless is honestly a good example of one of the cleanest and sharpest abstractions that I've seen anyone do, right? Like, it's almost like we call something outsourcing if it isn't mature enough yet, right? If we still feel the rough edges, then we call it outsourcing. And if we don't, then it just works. Like Gmail, like who thinks of outsourcing your email anymore? It just works. It's just a service, right? And something else I think that is interesting about serverless is the way you think about instrumentation through that lens. Like you just assume that you don't own the systems, right? You assume that the only point of view that you have is your code and what you can see by instrumenting your code, right? And I think that is absolutely the right pattern to follow moving forward, because most of the, like in the near and present future, like most of the systems that your code is running on might not be run by you. You might not have access to like the low level statistics and all that stuff, which is fine. Turns out you never needed it anyway. It was just all you had, so you used it, right? So we have definitely seen Honeycomb like being used by people who are using these more modern paradigms, and they're stitching together, stuff that they're running on various star as a services, whether it's serverless, like platforms, databases hosted by other people, it doesn't really matter. As long as you can instrument your code, you can tell, the hardest problem in distributed systems is often like not fixing the code, but figuring out where is the code that you need to fix. Right. And that's what observability is good for, is giving it to you at that level of abstraction and helping you figure out where it's coming from.
Awesome. Well, you talked to us a little bit about dog fooding and kibbling earlier. I'd love to maybe use that as a segue so we could get a bit more context on how Honeycomb is actually enabling that in context.
Yeah. If I can, my I'm getting a beach ball for my cursor right now.
Oh, we can fall back if we can't pull up the screen share for whatever reason.
Well,
there we go.
Is it good to go if I pull it up?
Yeah.
Big?
Yeah, I can see it.
Okay.
Okay,
yeah,
you're live.
We'll try. With the caveats that I have not given a demo in like a year or more.
No pressure. No pressure.
We'll just click around and look at some stuff though.
Yeah.
So this is the front page. Like if you let's see what data set, user events. If you sign up with Honeycomb, all you need to do is add a library to your code, and we do all the auto instrumentation for you, and you get popped into this view, which I would say that we found product market fit when we finished, the beelines, which are like the SDKs, and this, because just showing people those three familiar graphs of total request, latency, and error rate is so comforting and familiar. So let's see, let's look at, and then something that I love about Honeycomb is you're always embedded in a place in time, right? So we retain your history. I don't know if I'm gonna be able to. We retain your history, and we retain the history of all of your team too. So I'm just gonna go through and see what are some of the queries that people have been asking.
Cool. So these are sort of saved queries or shared saved questions that the team's asking.
Yeah.
And pulling that observability out. Cool.
Yeah, and let's see. I would like to show you something that shows something I can do a trace and maybe yeah, let's try that. This is our API server, Shepherd. Everything is very dog themed at Honeycomb because we have lots of dogs. And over here on the very right, you can see this is our schema, or not the schema, but we infer schema. So the way Honeycomb works is you just start sending these arbitrarily wide structured events, and we infer the schema from that. Then you can coerce any of the data types that we didn't guess right, but we mostly guess them right. And you know how if you're using a metrics tool, you can have a set number of tags, and none of them can be high cardinality or anything like that. Well, with Honeycomb, you can see all of the events have this many dimensions. We don't have a count, but it's a lot. I would guess a couple thousand. And maturely instrumented data sets tend to have 300 to 500 dimensions. So, and the nice thing about it is that with metrics tools, you have to capture a custom metric. If you want to do something, you just toss it on the blob, and it's effectively free. It is actually free for you because we charge per event. We don't charge based on how wide they are or on storage or anything. We just charge based on events, and it's effectively free for us because you're just appending another value to these events that you're writing in, right? Which is nice because you can't predict in advance what information is going to be valuable or useful to you, right? And anybody who it's a funny targeted.
You sort of have to throw everything over the wall and figure out what's valuable later. The problem, right?
Exactly. So I wanted to, let's look at, and this is the Honeycomb dog fooding. So I'm just going to take off this particular team name, and let's do maybe a heat map. My computer's so slow right now. Heat map on maybe log duration milliseconds. Let's look at app data size, data set columns. See what that gives us. The cool thing about heat maps, as you'll see, is that doesn't really have many outliers. Let's get a different one. I'm sure that they have demos that I just don't know. Map. I want like maybe, is it called query latency? Query start time, end time. Maybe just time. Come on. I don't know this data set at all. There's got to be something, maybe latency. No. Let's try user. Or elapsed.
Impressive how many different ways you have to analyze this data right out of the box.
Yeah, it is. Let me look for. So something else we can do is we can just look at the boards, because boards are where people collect useful queries that they've used. And I bet there's some interesting stuff there. Let's look at. Molly's useful queries. A lot of the ways that we think about, apologize, my computer is so slow, Jesus. A lot of the ways that we think about storing the queries that people use is kind of borrowed from the time that we spend at Facebook, where, you know, we use this really aggressively awful tool and it was unnavigable. So we would pass around these just like cheat sheets of like shortened URLs and like a couple of words or sentences to describe them. Let's see. Let's look at that. How many history searches? And despite how slow my computer is, we actually target like 1 second for the 95th percentile for queries. So this is an artifact of my. Yeah. Okay. So let's look at Heatmap of log time and total duration. That's probably interesting. Maybe body size. And this data set looks like it is there's not much in those heat maps, are there? Maybe I think Sarah Ram would be interesting. The cool thing that I'm like wanting to show you, maybe in that one, is something we can do with, yeah, page load. I bet that has an interesting heat map. Page load. Because like, all right, there's a heat map. All right, we're just going to pretend that this is something interesting right here. And I'm going to, whoops. Well, there's a trace. That's not what I wanted to show you. I want to go to bubble up. And then, like, if I was like, oh, this is interesting here, then I would just draw a little loop around it. And what we do when you draw a little bloop around it is pre-compute for all of the dimensions, both inside the bloop and outside of it, and then we diff them and sort them. So anything that's interesting or different about the thing that you circled will like sort to the top. So you can see, like, you know, one of the hard problems in distributed systems debugging is that, you know, maybe you find something And you don't realize that that isn't the only thing, but it's like, actually, like these events need to be different in these 5 or 6 ways in order to be an error, right? And so this is a great way that you can just see at a glance, oh, the things that I cared about and circled are different in these ways from all of the other events. So
that's pretty interesting. I don't know that I've seen something as detailed as this.
Yeah, nothing like this exists actually anywhere. And the reason we're able to do this is because of the arbitrarily wide structured data blobs, because what it does is it packs all that context together, right? It's saying that all of these hundreds of fields, these are all these values that were true for this event when it ran, and that lets you do all of this like outlier correlation and stuff. It also lets us do these really cool SLOs, where I know that there are other people who have SLO products out there, but they don't have ones, and we have Liz Fong-Jones to thank for this, of course. They don't have ones like ours where you can literally, you can define it. You can see like what your budget is. You can see, how many more errors you can have over the next month. And you can also see here is the distribution of all the events that are failing this server SLI, this service level indicator. And then below that will come like a bubble up style thing where you can just see what's different about all of the error events.
Wow. You said earlier a custom storage engine. So does that imply that under the hood, the databases that you're using to sort of calculate this stuff is all custom? You built your own custom?
All custom.
Wow.
Yeah.
What were some of the major considerations that went into designing your own custom storage engine?
Well,
I'm sure there's a lot.
The things that you care about for like observability and monitoring are very different from what you care about for most of those databases. Like our motto is, fast and close to right is better than perfect, right? Which is not what you typically want to associate with a database or data storage layer. Sorry, yeah, getting dinged. It's okay. So we do our fan out and scans to like merge queries and return them to the users. And if one of those nodes is offline, like we want to just like time out and just like tell the user this query is missing 20% of values, but we still want it to be fast, right? Instead of waiting for it to return. With databases, you typically don't want that. We also we wanted it to be schemaless. We considered using Druid for a little while, and then we realized we would have had to rewrite like a third of the database just to get that schemalessness, because most databases really want you to define a schema, and we just wanted people to be able to throw in whatever they wanted whenever they want to and stop sending it whenever they want to. So that was pretty core to us too. We wanted it to be horizontally scalable so that we could just toss more storage on. And in fact, the V2 of the storage engine that we've kind of been working on over the last couple of years has moved a lot of it to serverless. The queries are actually run by Lambda functions, and the data ages out of the EBS provisioned IOPS volumes, and it ages out into S3. So if you're running a query like this query here, because it goes over the last month, most of that was being run on S3 by a Lambda job instead of being run on the instances itself.
Got it. So you're sort of partitioning out different kinds of data and processing it relative to its need to be real time or not.
Yeah, I mean, when it's newly, like when data comes in the API, it gets dropped into Kafka, and then Kafka queue gets like consumed by instances, right, and laid down into these immutable files, and then those files slowly get aged off into the cloud.
Got it. Okay, that makes sense. That's impressive. Wow. Well, thanks for this overview of how it works.
Yeah, of course. There's a really detailed, if people are interested in the guts of the storage engine stuff, Sam Stokes gave a talk at Strange Loop in 2017 that really in depth like described everything that we've been doing up until that point. And we have some blog posts on the Honeycomb blog that describe some of our efforts in serverlessing the database.
Yeah, I'm gonna check those out after.
Yeah, and would love to any links you want me to put in kind of the description. We can put those into maybe a link drop section. So we'll put a connection back to you, your Twitter, any Honeycomb blog posts, and anything else that you'd want.
Absolutely. Wish I could have given you a better demo. I should probably practice those. It's been so long since I've had to do any demos.
No, we like it real. We like it real. That's
what you got.
That's how we like to do it, is dive in and see see how it works. I mean, it's great to actually see how you are working with your own product as well. I mean, I think it's useful, especially as somebody who's going to go check it out afterwards.
You know how long it's been since I've gotten to write new code and build a new thing? It's been ages.
Yeah, Kyle somehow, he doesn't want to. He loves to keep getting back in there. So
yeah, I've just found that I'm fundamentally motivated by doing what must be done, and I have a team of great engineers, and like that's not what must be done by me right now. So for the time being, I'm in marketing, but that's how I'm going to know that we're successful, is when I can go back to engineering.
Yeah, it's kind of this thought of, I was reading this rereading this book about life philosophies, and effective altruism is the latest, and it's just kind of comes with that mentality that you were just explaining, right? Where can I have the biggest impact, and then sometimes that, that's the nice thing about being a founder, right? You can move into these different business functions, and you get to explore and try a lot of different things.
I guess it sure sounds like it should be more free than, I don't know. I've always really loathed the cult of the founder in Silicon Valley. Like, I find it aggressively off-putting. But yeah, I think that I probably could do whatever I want, but I feel more constrained than that. I feel like I need to do what needs to be done.
Yeah, I think of my job as I try to do the things that can get done, which hopefully have an impact. And if I'm doing a good job, then they do. And if I'm not doing a good job, then they don't. But generally, I just always try to look at the next thing that I potentially can solve quickly, and hope that it's impactful, not just for the team. And sometimes they get in the way. That's kind of the truth.
Yeah, true.
Well, we're a little bit over the hour. Thanks for staying a little bit longer.
Totally.
And do you have any last words that you'd like to share? Any shout outs? And where's the best place to find you?
You can find me at honeycomb.io or charity.wtf, or Mipsy Tipsy on Twitter. We have a very generous free tier. If people want to sign up, try it out. It is, for now, one of the Lightstep is also an observability tool, I would say, but I would say that we are one of the 2 observability options that you have if you subscribe to my technical definition. And if you think it's a generic synonym for telemetry, then there are many other tools that you can also try.
Amazing. Well, thank you so much for coming on. That's all the time that we have for today, and I'll wrap up with our final phase out. And thanks for coming on, Charity. It was a pleasure.
Thanks for having me. It was great.